How do you determine whether a specific automated test is of good quality? Unit test, integration test, does it matter? How do you say whether a test is good or bad? What makes a good test? I think you can't definitively say a test is 100% good or 100% bad. Most tests are somewhere in the middle. It's mostly gray area. Even worse, it's mostly trade-offs. You're trading this for that. You have to pick between what you want to optimize for. And it's those trade-offs you should pay attention to. Let's look at how to discuss in your team whether tests are good or bad. The first thing I want to talk about is mocking. For every test you write, you have to make the decision. Will I include a specific dependency that the code I'm testing needs? Or will I mock that specific dependency? It doesn't matter whether that's an auto-generated mock or a manually written mock. Will you mock the dependency or will you include it? Mocking is a trade-off. When you mock something, you're deciding to not test the link between the code and the dependency, or the code and the mock. You're not testing that link, you're not testing that integration. So when you mock something, you're decreasing the system under test. The scope of what you are testing is suddenly a lot smaller. You're focusing very tightly on something very specific. Mocking can be a good thing or a bad thing. It's really a case-by-case situation. If you have lots of tests that only test very specific things and they mock all their dependencies, then you have no coverage for the integration between all these different units, modules, classes, functions. It doesn't really matter. Different things. And if you have no test coverage of that integration, then you are not mitigating that specific risk. But if you do already have that coverage, maybe it's a good idea to mock something because you can now focus on something very specific. And this is something that was not covered yet. But when all or most of your tests mock all their dependencies, you basically have no integration tests. You have only a very thick layer of unit tests. And your software isn't tested in reality the way it's used in production, where all these integrations are actually executed. Then you need to move some of these unit tests to the integration level. You need to start to mock less so that you get more confidence in that the integration won't fail. Mocking has a cost. You buy being able to test cheaper and quicker, but you pay with confidence. Your test represents reality to a lesser extent. So mocking is a case-by-case decision. The second thing to talk about is what risk a specific test is mitigating. And you should think of this in the context of the other tests. The coverage overlap is what you want to be talking about. Is this risk it's mitigating for this specific test, is it something different than this other test? Or are they actually mitigating the same risk because they're mocking the same thing? They have asserts that are very similar. They're testing the same module. Maybe there's no value in having them both. Maybe you have no specific test for that system under test, that class, that module that you're testing. You have no specific test that doesn't mock anything and uses these type of asserts. So there's no coverage for this specific, there's no risk mitigation for this specific risk. An example of coverage overlap is thinking about two different modules or classes. Module A, Module B. They both have their own unit test suite. So if you have unit tests for them, then you have to make sure that they're unit tests in the sense that they mock the other's dependency. So whenever class A needs class B, that in the unit test of A, B is mocked. And then if you then want to write an integration test, that you are not mocking A or B for all the integration tests. Otherwise, you're going to compete with the unit test. You're going to have coverage overlap with the unit test. So the unit test should be the things that's mocking all the dependencies, focusing on just the unit. And the integration test is the thing that is not mocking any of it. And then you need to make sure to focus your integration test, that higher level test, on the interaction and the communication between A and B, not the functionality of A individually or B individually, because that's the stuff that's covered. That would create overlap. So how do you write a integration test that's focused on interaction and communication between two classes? For starters, to not test anything in your integration test, any of the functions in the methods in these classes of A and B that don't trigger communication. If there's 5 methods in A and only 2 of them actually trigger communication with B, then you don't want to write tests for the other 3. You just want to write integration tests for these 2 methods that trigger interaction. And besides these basics of unit and integration to mock or not to mock, I advise you to put the assumptions that you make about how your code is used that are difficult to write in code, to put these assumptions in your test. Like, this class is always supposed to be used in this specific way, or these two classes are working together in this specific way. Yes, you can use them technically in other ways because they're just functions. You can call them in many different ways, but we're using it this way and not that way, and that increases the documentation value of your test suite. Another thing to pay attention to is the asserts you have in your test. What type of asserts do you have? Ideally, a test has so much focus that it has just one assert and a very descriptive name that matches what you see in the code line of the assert. You can have multiple asserts if you really are sure that these asserts test actually the same thing, but often you don't need multiple asserts. Often multiple asserts are actually covering different types of risks, and they should become their own test case. Asserts should almost never depend on the internals of the system under test, the code you're testing. The moment you start doing this, you tight couple yourself to the implementation instead of the interface. And this is a general best practice of programming. You should always couple yourself to the interface, not to the implementation. If you don't, it's called a leaky interface. When your test is coupled to the implementation instead of the interface, it makes refactoring harder. Because suddenly you need to change a lot more code, which will cost you a lot more time. So it is more expensive to change this kind of test, to change this kind of code. If you want to change names, you're refactoring around, it will be more costly. One of the goals of the suite of tests as a whole is so that you have the freedom to refactor with confidence and with ease. And you will be breaking that if you tight couple your test case to the internals of a function. Another common mistake I see is writing asserts for things that your type checker could take care of. As soon as you see asserts which test for types, investigate, because very often the answer will be, we could actually specify this in our types and now we can delete the test. Another thing to pay attention to is the number of false results you get from a specific automated test. The moment a test becomes flaky, you know you have a problem, you need to investigate. A false negative is a test that fails when it should not. So when your code is not broken, but your test fails. And a false positive is a test that succeeds when it should not. So when your code is broken, but your test does not fail. If you have these false results happening too often to a specific test, then you can say this is a useless test. You can say that the cost of having the test is higher than the gain. And the remedy is to delete the test. It's not worth it. This test has no value. Another thing to pay attention to is the readability or the understandability of the test. Can everybody on the team really understand what this test is covering, what risk it is mitigating? Are you using the AAA pattern? Why were these asserts picked? Why were these things mocked but not these other things? And when you know the answer to all these questions, does the name of the test still make sense? Does it actually increase your confidence? Is the test useful as it is? Do we want to rewrite it slightly because the code we are looking at right now is not exposing the answers to us in a very clear way? In conclusion, this is not a definitive list. There's other things you can pay attention to, but these talking points are the things I pay attention to first when looking at specific tests. Having said that, looking at the quality of individual tests is very useful, but it should not be the only thing you do. You should also look at the quality of the suite of tests as a whole. Does it make refactoring easier? Does it actually serve its purpose of increasing the confidence you have and speeding up the way you can do releases to production? Determining whether a test is good or bad can be difficult because it's not a straight yes or no answer. So I recommend to have loads of tiny discussions in your team with these talking points to determine whether this is the direction you want to go with the suite of tests as a whole, but also with specific tests, whether you think of them as good or not. But above all, the most important question is, are you scared to release to production? Because if you are, it doesn't matter how good the quality of the individual tests is, the suite as a whole is missing the point. The point is to release to production more often with very high confidence. And that's it. I hope you liked it. I hope this was useful. If you have any thoughts or if you have an idea for a future video, let me know in the comments and subscribe. Thank you very much for watching.